So what is a comparison table? Elements are R comma L comma C, voltage equation, current equation, power equation, heat or energy. V equal to IR, I is equal to V by R, and the power is equal to I square R or V square by R, and the heat is equal to I square RT joules. I square RT joules. And V is equal to L di by dt equal to L di by dt. I is equal to 1 by L integration of V dt. Power is equal to Li di by dt. And energy is equal to half Li square. Where V is equal to 1 by C integration of I dt. And I is equal to C dV by dt. And the power is equal to CV dV by dt, and the energy stored in a capacitor is half CV square. So this is a comparison table of the passive elements. So passive elements are which are not capable of delivering the energy to the external circuit or external elements. That's why it is called the passive elements. So individually it is not capable of delivering the energy, that is L comma C. It stores the energy. So battery also, if you take a battery also, while we are giving a supply through the charger the battery will be stores. Once it will be inserted into the phone, the function will be starts, the battery will be discharges. So this is about the passive elements. Okay, and so the classification is very important. 5 classifications. And active elements and passive elements, linear elements, non-linear elements, linear elements and non-linear elements, lumped elements, and distributed elements. Okay, so this is about the classification of complete picture of the classification of the elements. And from this, what are the objective bits are coming? So what is the internal resistance of the ideal voltage source is 0. Internal resistance of practical voltage source is small. Internal resistance of ideal current source is infinity. Internal resistance of practical current source is less than infinity. That is called the very high value. And also energy stored in an inductor formula. So half Li square, energy stored in a capacitor formula is half Li of CV square. And suppose if a charge is how much current is flowing, if a voltage is see clear here, if a voltage is 200 volts, and the resistance of the oven, so resistance of the oven is 1000 ohms, resistance of the oven is 1000 ohms. If a voltage is decreased to 180 volts, now what is the resistance of the oven is okay, and the power is equal to, let us say this is 3 kilowatts. Power is equal to 3 kilowatts. We won't change the oven resistance, that is 1000 ohms. Now what is the p value? So this is a small question only, and let us say this is V1 R1 and this is also R1, both are same, V2, and this is P2 and P1. So is there any relationship between the power and voltage? So power is equal to V square by R. So if you take a oven, so oven is like this, oven. Okay, so oven resistance is fixed here. Okay, you are applying a voltage source from 200 volts to 180 volts, you have decreasing this voltage. So power P2 by P1 is equal to V2 by V1 whole square here. What is the P2 now? P2 is equal to P1 into, what is the P1? 3000 into, what is the V2? 180 by 200 whole square. And this is 200 into 0.9, so 3000 into 0.81, so maybe it is 2.43 kilowatts. So it's a very simple logic. Is if a voltage is decreased, what will happen? The power is also decreased. So this is very important. And coming to the Ohm's law, so if you take a Ohm's law here, so this is resistance is 1 ohm and voltage is 5 volts. Now what is the current which is flowing through the 1 ohm resistance? Very simple. I is equal to pi by 1, that should be equal to 5 amperes. 5 amperes. If you take a inductor value, the inductor current is 5 amperes and the units of inductance is Henry. Units of inductance is Henry. Let us say this is 2 Henry. L is measured in Henry, and as I am applying a voltage source, right? Okay, as I am applying a voltage source here, what will happen? So find the or calculate the energy stored in inductor, half Li square. L value is 2 and I square is 5 square, so this is 25 joules. 25 joules. And if you go for the capacitance value, that capacitance value, okay, so you will take 100 microfarad. 100 microfarad. The current is 100 amperes. So what is the energy stored in that capacitor? Half CV square, half into what is the C value? 100 into 10 to the power of minus 6 upon into what is the V value? What is the V value? See here. So you will take 1000 volts. Sorry, here this is not a, so current is not required here. So 1000 volts of CV square, V square, 1000 square. So this is 2 into 50 here. So 50 into 10 to the power of minus 6 into 1000 means 10 to the power of 3 whole square. These two are cancelled. Then the 50 joules. 50 joules. The additional formulas which are required for the capacitance, capacitance is where C is equal to epsilon naught epsilon R A by D. D is the distance between the two plates. D is the distance between the two plates, and the area between the two plates, epsilon naught or epsilon is called the permittivity. Epsilon is called the permittivity. Okay, so this is about the small problems on resistance and inductance and capacitance. Now tell me, what is the capacitance is measured in what? Farad. Inductance is measured in what? Henry. Current is measured in what? Ampere. Resistance is measured in what? See, resistance is measured in ohm. Okay, and resistance is measured in ohm. Inductance is measured in Henry, and the capacitance is measured in farad. Capacitance is measured in farad. Okay, and current is measured in ampere. EMF is measured in volts. EMF is measured in volts, and electric potential is measured in volts. Potential difference is measured in volts. Power is measured in watts. Energy is measured in joules or kilowatt hour. From this, definitely you will get one objective question. So from the measurement. Okay, and next one is conductance. What is meant by conductance? This is very important. Conductance is represented with G. Conductance is represented with G. As the name itself, it is a conductance. It allows the electrons. What is my resistance? It opposes the electrons. Conductance means it allows the electrons. So which is the inverse of resistance is called the conductance. What is the units of resistance? Resistance units, and what is the units? Ohm. So reverse it. Write in the reverse order. Mho is the units of conductance. Resistance symbol, unit symbol is like this. Reverse means like this. Okay. So conductance units are mho. Conductance units are mho here. So these are the sample questions. Okay, and a classification of elements and how many elements are there, and what are the passive elements. So R, L, C, what are the properties of resistor, what are the properties of a inductor, and what are the properties of a capacitor.